Entrepreneurship. Why do startups fail? That was a really powerful session. We had guest speakers. They are owners, I call them CEO and co-founders of entrepreneurs of business. And luckily enough for this part of this session, this SADC, both speakers, both guests are actually tech wise. So we had the co-founder of AI Tech, and also we had the other guests too. It was a powerful session for us. And if you were in this session, if you're in the last session, please like can you just verify? Can you just raise your hand in the chat room? If you're in the last session last weekend, please let me just know in the chat room. And I hope I'm audible enough, please. I hope you can all hear me. I hope we can all hear me. Please, if you're on the call, I know you're listening, just give me a sign in the chat. Okay, Temi, yes, thank you. Okay, so like I said, if you are in the last session, please can you just signify in the chat room if you're in the last class? That was the entrepreneurship combined class. Oh, nobody was in the class. Okay. Oh, Temi, you were. Temi, can you give me your key takeaway from the last class? Just one, two, anything. Just give me something that you took away from the last class. Anybody to Emmanuel, Anastasia, if you were in the last class, tell me something. Tell me your key takeaway. Samson, I think Samson was in the class. What was your key takeaway from the last class? I'm waiting. Please let's make it interactive before we invite our guest speaker, Mr. Ayoola. I can see him on the call. What was your key takeaway from last class, the entrepreneurship class and the injection attacks, whichever session? Okay. An entrepreneur is one who creates value. Yes, you are right. You're right. You're right. That's a very, very big lesson from the last class. For me, I learned the key takeaway for the last class for me was you start up whatever you have with what you have. You start whatever idea you have. Don't think about funding. Just start something. Just start doing something. Funding will come. Whatever idea you have that you've placed on paper, you've analyzed, start it. That your startup, your tech startup, just do something. And also, you should be flexible to change. When you see the trend, the market trend is moving from whatever you're doing, as a tech inclined person, we all are. You try to move when you're maybe you're building e-commerce websites, and you see the trend is changing to people building blockchain or something. You move your business to you. You tweak your ideas towards that lane. So if you're not in that session, please you can go to the YouTube channel and you listen, you study, and you make sure or you get yourself on that lesson. So without further ado, today we are
Emmanuel, just before you continue, I would also like to share what I learned last
okay.
week. I mean,
Okay, ma'am.
every body on this call, even if you're in this, you are a software developer. I mean, the purpose, I want to believe the purpose of all of us being here in this class is to be able to develop a particular application software that will solve a particular or a given problem, right? And if that be the case, when we develop such applications, we are not going to give it out for free. So that makes me an entrepreneur as an aspiring software developer, because when I develop these applications, I'm going to sell them to be able to make profit out of it. So while I'm solving a problem, I'm also making profit. So last class was very very insightful.
Hello, ma'am. I used to use, okay, I think she has a network glitch. Um, all right, while we wait for her, Samson, you dropped something in the chat room. When you were starting without funding, you use people around you to make funds through pay parifier. Yes, that was talked about in the last class also. You give a percentage to anybody for referral. Yes, yes, yes.
Hello, Emmanuel.
That
Am I audible now?
okay. Yes, ma'am. Yes, ma'am. We can hear you now.
Oh, sorry, I had a glitch right there. Okay, so I was saying that as an entrepreneur, or rather as an aspiring software developer, I know that if I develop these application softwares, I'm going to sell them to make profit. So as I'm solving problems, I'm also making profit out of it. So my biggest takeaway from last week's class is the fact that you have to build what people need, not what you think people need, because it was highlighted that most people would rather sit in their sitting room and think that, oh, I have to develop something ABC because people will need it, not knowing if they will actually need it. But it's important to go out, do your feasibility studies, and be able to build what people need, not what you think that people will need, right? That's one. I hope I'm still audible enough.
Yes, ma'am. Yes, ma'am.
Okay, so I also learned that as an entrepreneur, you should be ready to pivot. That is, you need to be dynamic, right? Moving on to higher steps. If you start from a particular level, you watch the environment around you and be able to pivot to something much more bigger and better that will solve problems. Do not remain stagnant, right? It's good to keep evolving in business to meet up with the trend. And like you mentioned, you have to start with what you have, right? You don't have to keep procrastinating. Whatever you have, it's important to start with it. And then I think one of the CEOs mentioned that it's important to build a tribe. When you are assembling your team, build a tribe, not a team. When you build a tribe, you're able to have people who have the same goals and the same aspirations towards helping that business of yours grow and scale. So, I mean, that struck so well with me, building a tribe, not a team as an entrepreneur. So these are different areas or different highlights for me from the last class. It was really an eye opener. So thank you very much.
Yes, thank you, Madam Edith. That was really, really, that was like half of the session. You basically summarized the whole session for us. So, the the last class, the link to the last class have been posted in the chat room. So please do well to um, click and add to your watch list. After this class, you get on it, you get yourself you the information, the knowledge there is not to be wasted. It's for us all. So please do well to get on that. Also, before I forget, in course of this session, a link will be posted in the two links will be posted, the attendance link, so you do well to fill the attendance. And also, while filling the attendance, you should know you should register for this course. This course is 100% tuition fee, but you have, if you would like a certificate at the end, if you want your certificate at the end of this course, you pay the registration fee. I think we all saw that in our email after registering. Also, a feedback form will be posted. A feedback form will be posted. You tell us what you think of the course so far. You tell us ways to improve. I'm sure my partner will post that in few minutes. So like I was saying, Today, we have Mr. Ayoola with us, and he will be taking us on linguistic realization of algorithm. Linguistic realization of algorithm. I mean, when we think about linguistic, we all know that is language. So this is just basically it's the process of expressing an algorithm in natural, normal, the normal English language. So that is basically I know there's a lot more than that. Mr. Ayola will probably be smiling right now, be like, what's this guy saying? It will take us through deep into it. Okay. Like I was saying, is expressing an algorithm in natural language or structured human readable format rather than programming code. So instead of typing out your long JavaScript, your long Python to 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 express out to for solution, basically you basically use English language. So it involves using natural language, like I said. English language, you use pseudocode. Some of us might be familiar with pseudocode. Pseudocode is a semi-formal way of analyzing is a semi-formal way of describing an algorithm. It looks like a programming logic, but there's no strict syntax. So what a syntax is a step-by-step way that you need to follow when you're writing a program, when you're writing a code. That is basically saying if you are not following this step, the first thing you do is you call your div. Let's say using HTML as an example, you call your div. Some of us might be familiar with HTML. So the HTML syntax is okay. HTML, you have your or you call in your div, you put your paragraph and all. But when you don't start with that, we all know the code is not going to run. You're going to have a bug. So like I was saying, so today we also use flowcharts for the linguistic realization of algorithm. Flowchart is representing algorithm using diagrams to illustrate decision points and processes. So this is where you use diagram. I know Mr. Ayola is going to fill us up. Don't let me take the lesson away from him. So if you're not joining with your PC, if you're just thinking you're just going to stay on this call just for the voice, just for the fun of it, please, I would like you to change your mindset, get on your PC, get your mind, get everything together, and this session promises to be knowledge filled and very, very insightful. So please, like I said, ensure you get really get your mind together for this course. And also, like I said, the feedback form, the attendance form, they will be posted on the group. The link to the Telegram channel will be posted. Mr. Ayola, are you with us now?
Yes, madam.
Okay. So let us all give Mr. Ayola a round of applause in the chat room as he takes up into this session. Mr. Ayola, the class is all yours, sir. Mr. Ayola, please unmute your mic. We can hear you.
Thank you very much. Can you hear me now? Am I audible?
Yes, you are audible, sir.
Okay, thank you very much. Good morning, everyone. How you doing? Thank you for joining to this class. I'm so much happy to be here. And thank you to all the management of Transformation College for giving me the opportunity to do this again. Yeah, linguistic. When I first saw the topic, I was like, oh, what's going on? Are we doing anything that has to do with English? But I think Emmanuel has been able to help us simplify everything, so I don't have to go back to what's really linguistic language. It's just an art of expression, you know, it's an art of expression. So the way you express yourself, the language you use to be able to express yourself, the computer language that is being used to be able to send programs within the computer system. So then you say linguistics. Linguistics, that is language, it just means language, language. That is the heart of expression. It's good to have you here, everybody. Thank you very much, Emmanuel, for that. Thank you very much, Madam Edith. Thank you for everyone joining. So before I start this morning, I really want to know my audience. That's what's really helped me to, or what will guide me on what we are really going to be doing this morning. I really want to know my audience. Yes, I always like that. I want to know my audience. So in the chat room, in 1 to 3 minutes, I want everybody to tell me what's your background. Are you an IT person? Are you a computer science person? Let's just tell me your background. I want to know those that I'm really interacting with this morning. And in just 1 to 2 minutes, can we quickly do that, please? I want to know those that I'm going to be interacting with this morning. Are you an IT person? Are you a computer person? Do you have a computer science background? Or you don't have any background at all? So please quickly, let's quickly go to the chat room. I think this will be beneficial so that I don't have to go much more complex and leave those that are, I'm a beginner, but this program have been helpful, beautiful. That's good. Thank you very much, Samson Agbaje. Yeah, I need more people to come in the chat and tell me what your background really is. What your background really is. Are you a aspiring developer? Are you what do you like? Why are you taking this course? Okay, Anastasia says I have an IT background. Great, great. Okay, so when we're talking about programming language, when we're talking about compiler, when we're talking about algorithms. So all these groups be are new to everyone on the call. So I want to know, I need 2 or 3 more people. Thank you very much. Marvin, okay, good to see you here. I know you're not an aspiring to be a cybersecurity expert. You're a cybersecurity expert. Yeah, good to see you, Marvin. Yeah, okay. Who again am I having again on the call? I need 1 more person or 2 persons. 1 more person, so that I won't lost you. I need to know your background. I need to know your background. I need to know what you really know about software development. What's your background? Okay, front. Okay, beautiful. Okay, I think we can start. We can start. We can start. Thank you very much, everyone, for joining this class. And I want to assure you, it's not going to bore you. I'm going to take you from the fundamentals. We're going to do some practicals today. Yeah, thank you. I'm beginner at cybersecurity. I have background in computer science, but I'm not so don't worry. Um, at least everybody on the call has an idea about what uh software development is. Like you have an idea. You might not really have done something in relating to that, but at least you have an idea. So this is what we're going to do. Keep your system close to you. For those that don't have their system, keep your phone very charged. Today we're going to be having some lab exercises, and I'm going to be giving you, I'll try my best probably to be able to post some of my codes for you that I'm going to be running, or probably ask you to go and do it yourself. So don't mind me. I'm more of a practical person than taking you more of the theory. So what I'll be doing this morning is that I'll be laying the foundation, and by the time we come back from break, then we'll be able to uh, start our practical. So what you just need to do is make sure your internet is good, make sure you're not far. We're going to be doing more C programming today. I'm very sure a lot of us have heard about C programming, C programming, C programming. So we're going to be running some live codes. We're going to be seeing how it works. I'm going to be showing you the environment. I'm going to be showing you don't need to install anything. So we'll be using the web versions of our compiler. So if you don't have a system, it's not a problem, but it's good you have a system so that you can be able to have a feel of the environment. And then if you're using your phone, be rest assured you can surely use your phone to be able to run some of these lab exercise that will be given today. So it's good to have you on the call again. Once again, I'm your driver for this particular course. My name once again is Ayoola Diekola. And funny enough, this is what I do every day. I love solving problems that work using software. You know, I love solving problems every time. So every day that I'm on my system and I'm doing some other things, the next thing I'm thinking is of solving the problems that can be used by everybody around me. So you're happy to be in this particular training, and I'm very sure at the end of the day, you will go back home, confident that you too can run one program or the other using C programming. So permit me to share my screen, and if you have any question, please you can just raise your hand during the course of the session, and I'll be here to gladly respond to you. So as I said the other time, I mentioned that when we say linguistics, I would call it, I will give you a more definition. I'll just say it's more of an art, A-R-T. It's more of an art, than a way. Do you understand? It's more of an art, the way you approach a particular problem, the way you represent that particular problem, the way you move towards making sure that a particular problem is what is solved using what a programming language, or probably we follow a method of algorithm to be able to achieve this. So we're going to be talking about linguistic realization of algorithms, and low-level programming languages. And one of the things I'm going to be talking about today is understanding computer models and programming approaches. So we're going to be continuing again next week from wherever we stop today. We'll continue from there. And what are you going to learn in today's session? What will you be learning in today's session? We're going to be talking about how algorithms are realized, linguistically in programming languages. The relationship between computational models and the programming languages. I'm also going to be talking about differences between high-level and the low-level programming languages. We'll also be talking about real-world applications of programming models. Don't forget that I said I'm going to ensure that today we have a nice time to have hands-on, on writing C programming. So it's going to be very beneficial to everyone on the call. So let's look at the learning objectives for this particular course today. We have models of computation, we have the building of C programs, we have parallel programming models, we have application of programming models. So today, basically, we are going to be talking about the models of computation and the building of C program. Before I move on, why does this particular topic matters? Why do you think this particular topic matters? The linguistic realization of algorithm. Why do you think it matters? Do you know that programming languages translate human logic into machine executable codes? Let me repeat that for you. Programming languages translate human logic into machine executable codes. We're going to be looking at all the way those are done today. You know, when I said linguistic the other time, I never give you a definition. I said it's more of an art of representation, right? So, you know, representing whatever human logic is and translate it into what machine can really understand. So why do you have to also learn this particular topic today? You know, to understand that low-level programming languages enables direct, sorry, please. Low-level programming languages enables direct interaction with hardware for high performance. So low-level program languages, they are not very heavy. So that's why majority of your computer operating systems, majority of all these bigger systems outside there, they are built using a C programming. They are very what? They are very light. They are light. So another thing that you need to understand in learning this particular topic today is that to be able to understand the concept of linguistic realization of algorithms, you have to know the concepts of programming and software development. So I'm very aware that you've done a lot of basics in application development. So now we're going a little bit more higher to be able to represent all the knowledge that we gathered initially in a real life scenario. So let's look at models of computation. To me, you asked what is a model of computation. You know, it only defines how an algorithm process input to generate output. Let me put that again. A computational model defines how an algorithm process an input to generate an output. So let me do like this. Permit me to write something here. So I say computational, so computational model, right, can be defined into brackets. So this is going to be the okay, so this is going to be the mathematical representation. So computational model equals to what? Inputs, right? To later give us what? Outputs. So, or we can say refers to how an algorithm process what? Inputs, then to what? Give us output. So let me increase this. So, okay. So computational model simply means that how an algorithm would process an input. So let me put it here. Processing of inputs to be able to give us what? To be able to give us a very good output. So this will solve a long problem of what a computational model really means. So you ask me again, what's an algorithm? And you know that algorithm are always used to what? To solve computational problems and do what? And create computational models. So look at it. Algorithms are used to what? To solve, look at this, solve computational problems and also do what? To create computational models. So example of computational models include physical devices that can run software, programming languages, or a design specification of such. Let us also look at a programming language as a linguistic application of an algorithm. So what does a programming language does is that it uses computational model, look at it here, to focus on defining notations for writing codes. I remember when Emmanuel was trying to express what a linguistic, the definition of linguistic the other time in computational models, it was telling you how you can represent algorithms. He mentioned flowcharts, right? You remember, right? And a lot of methods to be able to represent your algorithms. But the common method is always a flowchart. So whereby either you are solving a problem, or you are trying to create a model, or you are trying to create a project. The kind of method that is mostly common to use is what? Is your flowchart to be able to represent what? Your algorithm. And I remember in one of the classes, I think the first or second class, I remember the trainer really took us on how to be able to, I want to remember the example. He walked us through how to be able to use flowchart to be able to cook Indomie. Yes. Yeah, I remember. He used a flowchart to be able to process in cooking an Indomie. So that is what he's doing, is that he's trying to show you how to solve a computational problem using an algorithm. So the step-by-step model or step-by-step way to be able to achieve that is called what? It's called an algorithm. Let's quickly move a little bit ahead. There are different roles and as perspective within the world of computer science and software development. So we need to understand that software development is meant to only create working software. When I was introducing myself the other time, I said one of the things that I do basically is to do what? Is to create application that works. That is what I live for. So I look for problems and I do what? And I solve them. Or you bring your problem, then I use my computational skills, my programming knowledge, my ability to be able to use these computational skills to do what? To solve that particular problems. So you know that at the end of the day, the major goal of you becoming either a software developer or you being an application developer is to create a working software. Create a working software that can run what? On a hardware model or run on any type of devices, which itself uses a hardware realization of an algorithm that enables specific physical computers to execute software program. All these are just explain that when you are creating a software, you are able to solve a problem and create a working application that can work on any device that also uses algorithm to be able to function. Examples are your mobile phone, examples are your tablets, example is your laptop, examples are your screens. So they also use one form of algorithm which has been put in place to be able to put them together and also understand whatever application you are bringing to them to be able to function. So why software development? Just one answer: to be able to create a working software that can run on what? On any devices. So we have different types of languages. We have high-level languages and we have low-level languages. Java, Python, C#, and so on. We also have low-level language, which are also called assembly language. Those are C and the others. C programming. So a high-level language operates at a high level of abstraction, meaning that Low-level details such as the management of memory are automated. So in the other hand, a low-level programming language operates at a low-level abstraction. One of the advantages of a high-level language and also a low-level language to a high-level language is that the size is very small. With a low-level language, the size is what is very, very, very small. So we need to understand this, that most of the software are designed, written, and discussed in terms of how that particular program should work. Let me take this again. The kind of algorithm you are going to use for that particular software development lifecycle or that particular software or application you are trying to build will do what? Will depend on how it should work. Now, I gave an example the other time when you were being taught how to use flowchart to be able to cook Indomie. Do you know that when you are cooking Indomie, it's different from when you are cooking a white rice? When you are cooking a white rice, it's different from when you are trying to prepare a jollof rice. And when you are trying to prepare a jollof rice, it's different from when you are trying to also prepare a fried rice. And talk less of all these basmati rice, all these Chinese rice, they are all different. So the kind of algorithm you are going to be using, the kind of software to be designed or written or to be discussed or to even be brought to realization will be dependent on how that particular program will work. So an example of this would be a map-reduce model, which is used in distributed systems like Google search engine to produce search results for large data sets using complex algorithm. So let's move a little bit forward. Modern computers are equipped with something we call CPU. I'm very sure that all of you know what CPU really means. So if you don't know, CPU means Central Processing Unit. And you know that all the systems, all the computers that we have today has a particular unit that makes it much functional. And that is what? That is your Central Processing Unit. So in this particular Central Processing Unit comes as a chip, that's capable of executing any form of programs. So when you open your systems, you see that particular chip, or probably let me put like this, open your system now. You find it that there's a processor and you see the chip, you see the processor fan. You see that particular chip that you are seeing under that processor fan is called your CPU. How small it is. On desktop computer, they're a little bit more bigger. But on laptops, they're just very, very small. As it is on your laptop, is it on all other devices? So this particular CPU, you need to understand that it also relies on specific CPU instruction, which is being set by the ISC. It's called instruction set architecture. That's the ISC. So those particular models are being relied on the instruction that are being set by that particular architecture. We call it ISC. This defines the list of operations that the CPU can execute. So you start talking about the storage, you start talking about the size of files, you start talking about the memory. So the instruction set architecture, which is the ISA, are the one that defines how that particular CPU works. So let's look at the CPU, how it looks like. I'm very sure you can see my screen, and you need to understand that the CPU, which is the Central Processing Unit, has the following units. Number one is the processor, which processes everything that comes as an input. I see that comes, let me change this for me. Okay, so the processor has everything that has to do with your registers, your combinational logics, which makes your mathematical operation to occur. It also has your memory, it controls your main memory. Can you see it here? It also controls everything that has to do with the system, both the hardware and all the software systems. So now when anybody inputs anything using either your keyboard, sorry, okay, using either your keyboard or your joysticks. Sorry, I'm trying to type it out. Your joystick or through your camera. Once it accepts that particular input, it goes straight into the combinational logic. Then it goes straight to what? To the registers, which helps us to save. That's where all your uh, ROM is, which helps us to save temporarily, then send it straight to the what? To the control unit. So once it gets to the control unit, it interferes with what? The main memory to be able to save. Then it goes straight back to the logic and interpret whatever was gotten from the input, then send it back to output. So this is what you later see, either as a screen, which is on your monitor, or to your printer, which is what? As an output device. So whatever you do via your input coming through the what? Combinational logic through to what? To the register, to what? To the control unit. Then it sends it straight to the memory unit, then back, gives the instruction back to the instruction unit, then send it back to what? The combinational logic to ensure that whatever you are doing is right, then send it back to what? The output. So what I will tell you is that both the compiler works what? In the combinational logic. Your compiler, your interpreter, they are what? They are all residing in the what? In the combinational logic. So this is how the computer really works. So let me just move an inch forward. So we have types of computational models. We have types of computational models. Types of computational models. Number one is the Turing machine. I'm very sure growing up, you'll have heard what a Turing machine really is. You know, a Turing machine is what? Is a mathematical model that can implement any algorithm. That is a theoretical model that can simulate any computational algorithm. Another one type of computational model is what? Is the lambda calculus. This is it. Another one is what? Lambda calculus. The lambda calculus. So this lambda calculus is what is the foundation of functional programming languages. This is where all the programming language started from. It was defined by what? Alonzo Church and inspired by the what? Functional programming paradigm. I've mentioned two types of computational models. Now I've mentioned the Turing machine. I've mentioned the lambda calculus. Let's quickly look at how the natural Turing machine really works. Don't forget I said that it's just a theoretical model that can help us to simulate any computation, right? So it starts from down here. Can you see the external inputs? So moves to the controller, leverages the pattern, the matching or capability of your neural networks. Are you getting me? Then it reads whatever is in the header of that particular information that was being passed. Then moves straight to what? to the memory. Then for the memory, it comes back. Then comes back to the controller. Can you see it? Then moves again back to, if it needs to make some adjustments, then go back to the memory, come back to the controller, then go back to what? As an external output. This is just a simple representation of how a Turing machine really works. And I told you that's just a theoretical model. So it's either read or write. So when it's reading, that is, it's accepting, it's come back to the controller, then make adjustments. Probably you are adding more input, take it to the memory, come back to the reading of the head, then it go back to what? To the external output. So this is just a simple Turing machine explanation, how it works as a theoretical model that simulates any computation. As I said the other time, that algorithm described in an abstract model cannot be run directly. It does not work. So what we do with the algorithm is that it should be represented in a way that can show what can really be achieved in a real life sense. So we said here that software developers must implement algorithm, which means translating that particular abstract knowledge into what? Into a code using a valid programming language. Let me repeat that again. You as a software developer, we don't expect you to just be having something on your head and not be able to represent something that can really work. I want to be careful with the kind of explanation that I'm going to be using, because one thing that you need to understand is this. As a software developer, you don't just have to be writing code. Your aim is not just to be able to achieve that particular result. Your aim at every point is to be able to ensure that that particular code you are going to write gives relevance or gives a benefit to whoever it's meant for. So before you start saying you want to start writing a code, or you want to start writing a problem, or you want to start writing or writing a programming language that works, the first thing that you need to first have in your mindset or have on your head is to do what? Is to be able to know how to be able to structure that particular set of instruction before getting an output. That is where the algorithm works. So you need to understand that as a programmer, algorithm is a way of life. So the heart there, which is going to be the programming language or the linguistics of the language that you're going to be using. Do you understand? So I said the linguistic is the language, which is the programming language, right? And I said the heart, which is the way to be able to know the kind of language you are going to be using, is what? Is algorithm. So we can also have this mathematical formula here. Permit me to write it here also. Okay, so I'm going to say that algorithm now right, is equals to the language, or let's call it equals to language. Okay, equals to arts, and the linguistic equals to what? Sorry, equals to arts, and the algorithm is the way of representation. And linguistic is what? Is the art of representation. Why I have to be doing this mathematical formula? Because as a programmer too, we do more of what? More of representing, sorry, more of representing whatever we do in a mathematical way. So if your algorithm is a way of representation, then your linguistic is what? Is the art of representation. So an algorithm can help you achieve an abstract model that does not work at all. But with the language, you'll be able to achieve what will be able to work. So computer scientists have created terminology to make sense of the similarities and differences between all these programming languages. So for example, we have programming language like low level or high level. So this can fall anywhere on the spectrum. So let's look at low level programming language. Let's look at low level programming language. I will say that when we say low level programming language, we mean it has a low level of abstraction. It has a what? A low level of what? Of abstraction. So you don't have to think of how it's really going to work to the end. So what you just need to do is just find a way to be able to represent them and you'll be able to achieve them. And one funny thing about low level language is that they always are humanly written. They're always humanly written. So you will see what I'm trying to say in during the practical session. You see what I'm trying to drive at. So a high level language has high level what? Abstraction. So the way they think is so much different. The way they are being represented is so much different. So with high level programming language, you can be able to do a lot of things. Number one, usable of code. Number two, you can easily integrate it to any types of platform. So in low-level language, programmers must describe the type of algorithms in terms of the computer hardware that can understand them directly. Example, if I want to create a software application now, I can't use a low-level language. If I want to create an operating system now, I'll be thinking about using what? Using a low-level language. If I want to create a web application, I can't be thinking of using a low-level language. All I need to do is to do what? Think of something that can really be used across all systems. So generally, low-level programs execute faster. Remember I told you about the size of low-level programming languages the other time. I've been categorically mentioning so I'm able to understand that low-level language size, it's very small. So they execute faster, but are more labor-intensive to create and maintain. Let me underline that so that you can be able to take that as a note. So generally, low-level programs execute faster, but are more what? Labor intensive to create and maintain. Just imagine that I just want to create a one-page website and I need to use a low-level language programming. All of us on this call will be on it just to create that one particular page website. So apart from the downside that it has, apart from the upside that has a lower size it's faster. Are you getting me? The major challenge there is that it needs more hands to be able to finish just a simple task. To be able to maintain it, you need much people to be able to do that. So in a low-level language, the programmer is focused to think deliberately about how the computer hardware executes. So the finishing of the program usually executes efficiently. So low-level language depends more on compiler. Yes. More low-level language depends basically or solely on a compiler to be able to automate and convert high-level code to what? To be able to convert it to what? To low-level code. So let's move a little bit more ahead on low-level programming again. Said, you can think of low-level programming language in terms of cooking. So when you cook a meal from scratch, you control every ingredient and every detail of preparation. So the finished meal has precisely the taste and nutrition of that's what you desire. So an alternative is to prepare a meal that uses some prepared ingredients, example like Indomie. And when you do that, you lose a lot of control over details. When you are cooking Indomie and you are trying to cook jollof rice, what you do is that you can add all your ingredients the way you like it. But with, sorry, I was saying Indomie, noodles. So when creating or probably when you're trying to prepare your noodles, you do what? You just take the noodles, put on fire, put on your water. Then after doing that, all you just need to do is just add the seasoning, and that is all. But when you're cooking your jollof rice, you know what to do now. You first parboil the rice before you now start adding all your sauce. So let's talk about machine code. The sequence of binary digits that can be understood and executed directly by a computer. I won't waste much of my time here. It's also a low-level language. It's also a low-level language. Machine code is an example of a low-level language. So, a machine code operates in what? In zeros and ones. It's operates in zeros and ones. So, an example of what? Of a machine code. So you can say it depends or works with binary numbers or binary digits, zeros and one. I think I've been able to talk about the CPU the other time. We'll be able to talk about how CPU chip also works. And I think I was able to also tell you where you can easily locate your CPU or your processor chip on your motherboard. I was able to do that when I was trying to also. So this is an example of a CPU. And this is processor. I'm very sure if you're conversant with the opening of your system, you'll be able to identify this. So under it, there's a processor under this particular chip, and this is the CPU. This is what we call the CPU. So let's go talk about assembly language. Assembly language is also a low-level language in which every statement corresponds directly to what? To machine instruction using an assembly language instructions. So assembly language is a small step above machine code, but still a very low-level language. Don't forget we've spoken about machine language and we said it's made with zeros and ones, or say binary numbers. Assembly language is a little bit much more higher than machine language or machine code. So rather than writing the instruction in a binary format, it comes with a very predefined commands like add or move. So like add or move. So an assembler is a program that translates assembly language source code into the machine code. So this is an example. We have the move. So it's going to translate this into what? Into a machine code. This was the beginning of what programming language really means. So let's go move to middle level programming language. Middle level programming language. Don't forget that we started from low level language and now we are currently at middle level programming language. We said example of low level language are number one, the machine code, and number two, the assembly language. The assembly language. So machine code comes with what? With binary numbers, zeros and one, and the assembly language comes with what? With the predefined code format, which translates to what? To the machine code. Translates what? To the machine code. So now I'm moving to the middle level programming language. And what is middle level programming language? It's at the level of abstraction that is in between the low level and the high level language. It's between low level and the high level programming language. So an example of a middle level programming language, which is between the low level and the high level, is what? Is your C. C++2 is a middle level object-oriented programming language. Yes, C++2 is a middle level object-oriented programming language. I think I'm going to be giving us an assignment at the end of today's class, and we'll be submitting it or we'll be discussing it in the next class before we start the session. Next week, we're going to be talking more of next week more of the high-level programming language, more of the high-level programming language. Okay, so middle level code is a compromise that executes nearly as fast as low level code yet has some of the productivity benefits of high level code. So, like low level languages, every middle level language allows direct access to computer hardware. Don't forget that with low level, you don't have a direct access. We said we need plenty. But with middle level, what you need to do is to do what? Is to add just a little thing and you'll be able to achieve whatever you want to do. So a device driver is a piece of code responsible for connecting the hardware components such as video card or keyboard. A device driver, you need to understand that it's responsible for what? Connecting a hardware component such as video card or keyboard. So let's go look at this diagram below, how it summarizes the difference between the low level, middle level, and the high level programming language. Don't forget, one has a slower execution and the other one has a faster execution. And I said the other time, low level has a what? Faster execution. The high level has a slower execution, while the middle level has a minimal or middle execution. So this is what we are. So the so let's quickly move one step ahead. So let's move one step ahead. The middle level and the high level programming language. So as I said the other time, example of a middle level programming language was C and C++. So most of these operating systems that you see around, both on hardwares, both on your computers, both on your mobile phones, are developed using this middle level and high level programming languages. Example is what? Your C and C++. So you can check it up and you can check it up anywhere to be able to confirm. Even your Windows operating system was built using C and then C++. So compilers for high-level languages such as Python, Java, and C# are themselves implemented in middle-level languages such as C. Don't forget that I mentioned that just right away.
So looking at this, a high-level programming language comes from normal human language. You start from inputting whatever you want to input. Then it speaks if it's very high or it has a very high level language. Then it just breaks down to the middle level language, which is your operating systems. Then it goes lower to your C and then your C++. Then your hardware, which is the one that houses those particular programs, then interprets it, then takes it back to the human language as what? As a final or processed data. So let's quickly move to structured programming. Sorry, 1 second, please. Sorry for that 1 second break. So let's go talk about structured programming, programming. So in level languages and most of the high-level languages that we have, such as basics, some special statement called conditional statement like if or then, and probably some of the iteration that are called loops. Example of loops are for, go to, etc. So our non-structured operation that instruct the computer to jump to an entirely different part of the program. I'm going to be showing us some of these things during the course of the practical session that we're going to be having. So these sort of programs are criticized or are characterized for being messy. You understand? They are too much. Just imagine you have to write some codes and you have to write maybe 2,500 codes and you have to be checking for every condition. Check for every condition. At the end of the day, you're not able to reach what? To reach a concise end. So look at this, structured, unstructured. So for structures, if X is less than or equals to Y, then start, that is begin. Z is not equal to what? Y minus X. Then Q is equal to what? Square root of Z. Else begin. Z now equals to what? Y minus X. Q equals to minus square root of Z. So then end. Don't worry, we'll talk about this during the course. So this is the difference between a structured and a unstructured programming language. So most of the time, we are going to be talking more of the structure than the unstructured. So you can look at a high-level program and you can see how it works. So if var is greater than the current var, then do what? Output, the value that you entered is greater than the current. Else, also output what the current value is greater than the value that you entered. So some of these things are the things that I'm going to be doing. And I'm going to be giving you assignments to be able to do and submit for submit by next week of Saturday again. So let's look at examples of procedural programming. So I'm going to look at how it's being represented programmatically in C++. So take 2 pieces of bread, right? The first thing is that take 2 pieces of bread. Separate the piece of bread. Don't forget, get a knife, right? Get some peanut butter and jelly. So let's go at this together. Take the knife and peanut on the bread with the knife, right? take the knife and put some jelly on it. This an example of a procedural programming, how it's being represented. Then spread the jelly on the other side of the bread. Then take the slice of bread with the peanut butter and slice of bread with the jelly and put the two together. So for procedural programming, which are low-level programming, this is how the algorithms are being represented. But for middle-level programming, this is how it's being represented. Just a count is less than, then please enter the amount. If the count is less than something, enter the amount. Then check it again, check the length. If it's greater than the length. If the count is less than the amount, then check again the width. Then now check the area, length times breadth. What the procedural programming is doing is also what the high level procedural programming is also the algorithm in the high level is also representing. So the only difference is that the way it's representing is that one is much more structured than the other. This on the right hand side is much more structured than this on the left hand side. So as a programmer, I understand this more than going through this 9 processes of ensuring that I divide or slice a bread and then add peanuts to it. So procedural programming involves executing a series of imperative commands that use operating system features such as transport layers, system calls, and so let's quickly move on. Let's go talk about OOP. OOP is an high-level programming language, or I won't really speak to much of this so that I can be able to talk about it next week. Because next week we'll be talking more about the high-level programming language, which includes the object-oriented programming. And one funny thing about these things is that the codes are always very reusable. If you're not doing that, if you think what you want to do is becoming a middle-level programmer, which is writing operations that work with the or writing programs that work with the operating systems and the likes, you're good. But some of us that love solving real life problems, then you see us here. So an object has both data of variables and procedures that work together to represent a specific human example. Let me say a simple example of an object can be a rectangle used to represent meaningful concepts in real life. So that some of the rooms in the house or a person or robot, what it can do. So a robot can have a name, right, and a age, and can receive input command and respond or print a greetings as illustrated below. Before we do this, let me quickly get some reactions in the chat. Now, for a dog, right, what are the features of a dog? And what somebody should tell me the features of a dog and the features of a bird. Let me repeat that. What are the features, or what features does the dog has? And what, let's say, let us write 4 features of a dog and 4 features of a bird. Can you do that in the chat section, please? What are the 4 features of a dog and what are the 4 features of a bird? Please, I will do that in the comment section. Thank you. Somebody's writing. Thank you, dog. Yes, dog. D-O-G. What are the features of a dog? What features does the dog has? Dog, yes. I don't want to say it. What features does the dog has? And what are the features that a bird has? Bird, B-I-R-D. I'm waiting. Oh, do I need to call somebody on the call? Okay, thank you very much, Emmanuel. A dog has 4 legs, while a bird has 2 legs. Are you sure? A dog has 4 legs, while a bird has 2 legs. I don't want to believe that. Okay, another person. What are the features of a dog, or what are the features that a dog that's composed of dog, and the features of a bird? Okay, a dog walks and a bird flies. No. How do you know that a bird does not walk? So these are where the dog has 4 legs. Okay, a tail, ear, teeth. Bird has wings, beak, feathers, no teeth. Okay. A dog barks and a bird chaps. Okay. A dog barks. Okay, but I still don't know. I still need some features. I like what Temi just said now. I think Temi is getting it. A dog barks and a bird chaps. Okay, good. But that's not the common features. No, that's not the common features. No, that's not the common features. I mean, common features of a dog and a bird. I need somebody to just build me out. I think we have over, how many people do we have here? Over 70, yeah, we have 17 people here. So I need somebody to just build me out. What are the common features of a dog? And what are the common features of a bird? Both breathes in air. Okay, thank you very much. Let me solve this particular question. Because one thing that you need to understand as a programmer is that there's something we call attributes, behaviors. Those attributes and behaviors are what we use to be able to classify them into different sections. So when I'm talking about a dog now, right? I can say, I can say that a dog has 2 eyes, right? It has a nose, it has a hair, right? And it has what? It has a mouth. We can't say that a bird has a mouth. We say it has a beak, right? A dog has a tongue. A bird has a tongue, right? They both have 2 legs and 2 hands. A dog uses his hands to walk, right? That's the way we categorize it, because a dog will stand on his 2 legs and use the other 2 in the front to be able to do any other thing. But we categorize it normally as what? As legs. So now, a dog has furs, F-U-R-S. A bird has what? Feathers. Do you understand? These are the things that we really need to use to categorize them so that we don't mix them up. So that at the end of the day, when you want to identify one of them, don't forget they have common features and they have different features. So if you're going to categorize them, you have to ensure that you don't use their attributes to be able to confuse them, or the computer will just use their attributes to confuse them. I have to go through this lens so that you can be able to understand how they really works. An example again is looking at human being. We can say we have light-skinned human being and we have a dark-skinned human being. Why will you say that somebody is dark and somebody is light? You say the color is black, right? And the what? And the color is either yellow or amber or something color, but it's not black, or red. This person is a white man and it's what? It's a black man. So you need to understand how an attribute really works. So basically, high-level programming language uses just two particular things to be able to define that it's an high-level programming language. That is the fact that it uses a method and a what? And a attributes, an attributes. And I've told you what an attribute means. Attribute means behaviors. It means behaviors. So let's go move an inch ahead. Wow. Building a C programming language. Before I move ahead, you need to understand what a C programming language is. If you look at my descriptions from the start of this class to now, you find out that I've been able to help you break down what a C programming language is, what is being used for. Are you getting me? The only thing we've not done is that we've not been able to write fundamental elements of this particular language. We are going to be able to also talk about some of the steps that is involved to be able to develop a C program. All right? We are going to also understand the process of compiling it. Yes, we are going to be doing that today. I'm going to also talk about how you can link its usage, how you can also apply the version control, data types, constraints, variables, talk about input and output operations, arrays, pointers, structures, and union of data. So these are the things that we're going to be covering in this particular thing. But before we move on, let me just say this. A program is a set of instruction written, a set of what? A set of instruction written in a programming language that a computer can execute to what? To perform a specific task. Yes. So what you need to learn here is that what is a program is what? Is a set of instruction, written in a programming language that can help the computer to what? To execute a particular function. So whatever input that you are putting into it, that program or that particular function is being translated to be understood by the computer, and it's going to give a very concise output. So for example of a simple program, so I will say A, which is a variable, is 5, and B, which is another variable, is 3. Programmatically, we'll say assign 5 into A and assign 3 into B. So we want to carry out a arithmetic operation on this particular 2 variables, A and B. So what do you need to do is that have another variable sum and do what? Add that particular 2 variables A and B. Then you output is a print sum. Then this will be a string. Then don't worry about your head. Then it's going to give us what? 5 plus 3. Then to print that as what? Sum equals to what? Equals to 8. We'll talk about this in the next what's it called? Next hands-on. Don't forget, I said keep your laptop close, keep your system close, keep everything that you need, your internet very close to you, as we will be moving to the practical session in few minutes from now. So what are the basic components of a program structure? You have the header or documentation. This header or documentation, we call it libraries. Do you understand? We also have what we call comments. So the common comments in low-level language is represented as hash. The common one. Some are in high level, it is double forward slash. In most of the middle level program language, we also use hash. Yes, we also use hash. But in high level language, we use hash and this star. So you might be seeing these two or this. So it's always hash. So hash or this double forward slash or one single slash star, the star, then back forward slash again. Then another one is import statement, which helps you to do what? It helps you to be able to bring in all important libraries. Yes, all important libraries. And these libraries are the ones that helps your program to be very easy because it has already been written, pre-written programs. So all you just need to do is to import them, like mathematical calculations, like linear regression and the other and the likes. So another one is variable. Remember I mentioned the variables the other time. Variables are just used to hold data temporarily. They are always used to hold data temporarily. Example of variables is name, age, etc. So you just declare the variable name. So just to hold whatever you assign it to it temporarily. So we also have the function, the block of usable code that performs specific tasks. So you're going to be seeing that in our examples, and I'll be explaining everything to you one after the other. We also have main logic, we have the loops and the conditions, we have the error handling. The error handling is just to help you to manage exceptions, and the exception is just to give out whatever error that happens during the program, or probably if there was a crashing, it's going to help you report the crashing. So okay, let's go talk about C programming. Why do we really need C programming? Please take note of these things that I want to say now. Number one, it is efficient. Very close to hardware programming. It's efficient and it's very close to hardware programming. Yes. Number two, it is used in operating systems. Don't forget, it is basically used what? In operating systems. So for those that are interested in developing operating systems, you really need to learn C. It can also be used to develop embedded systems and also perform practical and also helps to develop performance critical applications. So these are always middle level programs. Do you understand? Your operating system, so your high level applications depends on this particular middle level programs to be able to run and later turn into to a low level programs that will help the systems to be able to interpret whatever you are, that is your zeros and ones. Just imagine that by today we don't have C, which has been used to develop our operating systems. Just imagine that I have to go and start learning how to understand what 0 1 1 1 1 0 0 0 1 1 1 1 1 1 the binary numbers, and now interpret it to what the computer. I'll just, even me, by the end of tomorrow, I'll just run away. So C was invented by Dennis Ritchie of Bell's Lab. So it was invented by, what's it called, by Dennis Ritchie. And why is C popular? I think I mentioned that already. Your Java virtual machine, your Linux, your Windows, your Mac OS depend on C, your Oracle database depend on C, your Cisco router depend on C. So you can see how C programming language is very, 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 very common across all application and hardware developments environment. So I said some of the products include Java, virtual machine, or JVM. So some of you just go to Java, Oracle site and download JVM. You know that was developed using C. Linux. A lot of them are using Linux, so C and some assembly language, and Python was also used. C was also used to develop the interpreter for Python, Mac OS kernel, the Windows. All of you have mentioned Windows more than up to time today. The Oracle database, the Cisco rather. So C is used in a variety of industries. So, for example, astrophysics, where scientists will write programs that simulate the motion of stellar bodies and control instruments such as telescopes and so on and so forth. So let me just quickly move on to little features of C. I've mentioned some of them the other time, and for the purpose of exams and probably some of the things that you're going to be doing, you need to understand that it's very efficient. I said that before. It's lower in expressive power. It doesn't consume more power. So portability, it can run on multiple computing environments. So modularity, refers to the process of dividing computer program into separate subprograms. Yes. So procedural and structural programming support, it adheres to the procedural and structural paradigms. So data types and operators, it also allow variables, also allow variables and also support different types of data types, different types of data types. So for the recursion support, which is where systems is being defined in terms of itself. Yes. So it means a function may call itself again and again. So like a repetitive process. It supports a recursion support or a repetitive process. Also pointers, it holds the memory addresses for another variable and points to that variable when needed. So it serves as a good pointer. So when you say pointer, it means it holds the memory address, something like storing it for a while, temporary address, and then when it is needed, it's being called out and used. So example of data types includes your int, where you say int a equals to 24. Int a, that means that 24 can only be an integer. So when we say int start b, so it is going to be expecting you for an input. So by the time you put that particular input, then the pointer picks it and add it to that particular b value. So it multiplies that particular b value. So it holds a pointer. And it can also help us to point to a particular number, variable, and at the same time store it for the use again. So all these things are the things that we're going to be talking about in this session, the next session. So to be able to round up this particular class for today, let's go talk about some of the data types in C. Don't be intimidated. I'm going to be seeing shorts. Short does not mean how tall you are. Short. So short means it can only take little amount of integer values. When I say whole numbers, so integers, it has that takes 8 characters and extend to a 32-bit characters. So we have long character, we can extend to 64-bit characters. So and so on. And so we'll talk about that in a very little while. So what is the most appropriate integer data types? Yes, what are the most appropriate? I also mentioned that in the other time. That is your short, your integer, your int, and your long for the following quantities. So okay. Now I think this is an example that we need to put, like the number of people on an airplane. The number of people on an airplane can be counted, right? So we are going to look at it. We can use an integer value for number of people. And if you are going to say number of people on the earth, we say long because it supports more values to be stored. The number of people in an household, you can say short. short, because this one will hold a 8-bit value. The long will hold a 64-bit value, and the int will hold an anything is greater than 8-bit, like 16-bit and what, and the 32-bit value. So the number of dollars in a bank account, will be what? A long value, not because some people can have trillions of naira. I remember recently, I was having an engagement with some people, and I was having an engagement with some people, and they were telling me the amount of naira that the banking industry scooped in just they scooped it in just a month. He said he has never had zillion before. So they left billion, they left million, and now they are moving to zillion naira. Can you imagine? So they left billion, they left million, they left billion, they left trillion. So in a month, they were able to make zillion. So if you are talking about that, so you talk about long. So this memory space depends on how you are going to define. I said this one will hold what? 8 bits. 8 bits. This one hold what? 16 to 32. While this one hold what? 64 bits. Characters. Okay, let's move on. So let's talk about developing C programming and how to really go around this. You need to understand that programmers working with compiled languages generally work using the circle shown below. So you get the problem. Number one is to get the problem, right? I told you, use your algorithm for this to develop your problem. I don't need to teach you how to develop an algorithm because I'm aware we've all done that during the starting of this particular program. Then after the algorithm whereby you define the problem and state out the language you are going to use, then the next one is the program development. Are you getting me? You choose the language. This is where the linguistic come from. So after doing that, then you talk about your compilation. What is going to compile it? Your compiler. Is it a C compiler? Is it a high-level compiler or interpreter? Then after that, it's going to interpret it. Number 4, interpret whatever has been compiled. Interpret. Don't mind my writing. Interpret, then it gives you what? Your output. So you can just do a favor, you can just screenshot this particular though I'm going to send this slide back to you, and we can see whatever I've written in it. So the first thing is when you think of your problem, that is the way you want to go about the problem. The next thing is to do what? To think about the heart, which is what? The language you want to use. Then you leave it for the compiler to do its work, which is after the inputting, you allow the compiler to do whatever you want to do. Then the compiler interprets it, then generates it back to you in a readable format that you and the system, or probably everybody around you, can really understand. So let's look at steps in C development or C programming. So number one, the algorithm development, program development, set program translation program. So you can look at this in your material I'm going to send to you. So the compilation process involves several steps. Number one is the compiler, which is the high-level language converts to assembly language. The assembler converts to machine code. the linker converts that from the what's it called, links from the compiler to the assembler, then back to the interpreter, then to the human interface. So this is an example. We're going to be writing an hello world very soon, and we are going to be closing for the day. Before we go for break, because we're going to be going for a 30 minutes break by 12, I need to let us understand something very important. To be able to recap this, what makes a low-level language a low-level language? Or what makes a language a low-level language? Number one, don't forget, it interacts directly with hardware. Please don't forget, it interacts directly with hardware. Number two, it provides fine-grained control over memory and execution, and that's a faster execution rate. But it requires what? More effort to write and debug. Those are the things that I've summarized from the beginning of this class about low-level languages. And I said example of low-level languages are what? Machine code, which uses binary instructions and execute directly by the CPU. Then number two, assembly language, which uses human-readable mnemonics or human-readable languages like MOV, like add. I showed you the other time. Then later translate it to what? To a machine code to be able to understand whatever you've been able to read. Then the last one is a middle level programming language. That is what? Your C language, which is what makes the lower level language and the what? And the high level language capability. So let's go look at some that I've also taught you in the last 1 hour thereabout, or 1.5 hours thereabout. And that is, you need to understand that the low level language, they are minimal, middle, they are moderate, and the high level has an high abstraction. So for the abstraction level of these three, number one, the low level language has a minimal abstraction. I've said that countless of time. So I also said that the middle level has a moderate, which is middle or moderate level of abstraction, and high level level has what? High level of abstraction. Example again of low level program language are what? Are machine code, assembly code, assembly code. Example of middle level language are what? C and C++. Then I'm not giving you example of high level language because I said we're going to be doing that next class. Another thing, we'll look at executional speed of these particular three programming language: the high level, the low level, and the middle level. The low level is very fast. I get you. The middle level is, sorry, the low level is fastest. The middle level is fast. Why the high level is slower? Maybe what I'll do is that immediately okay, let me do that here. Let's do that here so that I can drop it in your Control M. Okay, drawing a table. That is what's 4? It's a 5. Okay. So let's do like this. Let's do like features. Let's do like this. Low level into brackets. Example is assembly or machine code or machine code. We have the middle, which is middle level programming, which includes the C or C++. Then we have the high level. This one includes your Java, Python, what other thing? And what's it called? C#. So let's look at them based on different features. Number one, feature I'm going to go abstraction. Abstraction. So, sorry, this is right. Abstraction. So I have minimal. I have it's moderate. I said it's moderate, but I said that it's very high. So this abstraction level, let's do it like this. And I also mentioned that we have the speed of execution. Or let's call it execution speed. Execution speed. They will say this one is the fastest. This one is what? It's fast. Then this was very slow. Yes. And because this one has to go from the high level to the middle level, then to the low level. Then this one just go from the middle level to the what? To the low level. And this one just go straight to the machine. It interacts straight to the machine. So this one, let's call it usability. Usability. It's confirmed, right? So difficult, very difficult. Writing a C language is moderate, not bad. But then it's very easy. Yeah. So that's why most of the people you see now, they are always at the high level. They don't even go close to the middle level because it's just moderate. But the high level, just imagine I'm writing 0001 10000110 just because I want to write Ayoola alone. I want to write just Ayoola and I'm interpreting and I'm compiling to, and I have to first say, okay, machine, I want to write Ayoola. So the binary value of Ayoola is 011000100. Can you imagine? So hardware, let's say control. So this one is direct. I mentioned it very well. I just have to summarize this because I won't be going back. This one is moderate, and this one is indirect. This one needs platforms to be able to ensure that it works very, very well. So I think I'm able to let you understand this. So I've also ensured that I'm able to allow you to understand that developing middle-level programs and high-level programs, you need what we call variables, and that is the temporarily old data. You know, what we call it variables. Variables. We call it variables. We have data types. Data types which determine the type of the variables that have been declared. And we have the structures, the control structures. So the control structures are structures. So the control structures are the if-else statements, the conditional statements, and the likes like that. So also you also need to note this, that we have what we call the rules that binds programming language, programming writing or something. Let's just call it programming writing or writing of program. That the rules that binds writing of a program. So you also need to note that also. And lastly, we also need to understand what we call arrays. We need to understand what we call pointers. I've mentioned it. We need to understand what we call memory management. So these are all the things that we've spoken in the past 1 hour or 1.5 hours thereabouts. So it will also be made available in upcoming, what is this thing? What happens? Okay, so let me just put them into so that when you see it, there's the notes that you need to understand why you are doing these things. Why you are doing these things. So okay, so we're going to be going on a break. I think I'll hand over this to Madam Edith and then Emmanuel to take over from here. So we'll come back from the break. Then we are going to start with writing from basic C programming like Hello World to adding some of simple variables together, and it's going to be very lovely. Okay, thank you. Over to you, Emmanuel and Madam Edith.
Thank you, Mr. Ayoola. You've explained this so basic that I feel like I never took a computer science course before. So right now we are going on 30 minutes break, 30 minutes coffee break. Please join us back by 12:30. Thank you.
Yes, and please don't be late because we would start right away with the coding proper. And if you're late, you might be missing out from the beginning. So please be prompt and so we can start immediately after the break by 12:30.
Thank you for joining this class once again. As I said the other time, it's not meant to bore anybody. It's just to ensure that at the end of the day, when you say you've learned a programming language, you'll be able to understand the nitty-gritty of that particular programming language. Then you'll be able to run basic codes. Yes, you'll be able to run basic codes. So this afternoon, I'm going to be putting you through writing maybe like 4 to 5 basic codes. And then if there's opportunity for me, I can also paste my code for you directly on this place. Then I ask somebody to really run it, or probably I give a chance to somebody to run it pending the time that I'm going to be doing that. So I have few time for this, and I hope you are going to enjoy the class. So welcome back, everyone, and let's enjoy the session as we continue. So I'm going to be sharing my screen again. Very 1 second, trying to share my screen. Okay. Okay. Can I get somebody that can assist for a feedback on the who would like to do a walk around with me? Can I get a volunteer to just do a walk around with me? Who's going to unmute his mic? Can I get somebody who can do this together? I don't know. Who should I call? Okay, Marvin. Hello, Marvin, are you there? Hello, Marvin, are you there? Okay, let me look for another person. Tell me, are you there? Please confirm if you can hear me, please.
Yes, we can hear you, Mr. Ayoola. We can hear you.
Okay. I need somebody we can do a walk through together. Who's that? Who's that? I need a volunteer. I need a volunteer. Okay. Marvin is there. Okay, Marvin, can you unmute? Can you unmute? Okay. Okay.
Hello, sir.
Okay. Oh, Temi, are you there too? Temi. Please let me unmute Temi too. Temi,
Yeah,
okay,
I think
let's
Marvin.
Yes.
Marvin is unmuted. Why am I
okay, let the
unmuted?
three of us. Yes, Temi too is unmuted. So let's
Okay,
the three of us do it. Yes, because I want to confirm. But Temi, confirm you have your system with you. Do you do that?
Yes, I do.
Okay. And Marvin, do you have your system with you too?
Yes, I have my PC.
Okay, so what we're going to be doing is that we're going to be walking through this session together. So I'm going to be using the two of you as a feedback. So quickly before we start at all, we need a very basic thing to do, which is first, remember we said before your system understand whatever you are trying to code. And don't forget that we're currently working on a middle level language. We said that you need a compiler, that's going to translate it to a lower level language, right? So we said we're going to need a compiler. So now I'm not going to be allowing us to install anything. There are this free online tool that we can use. So everybody go to this website, www, or anyone that you want to do, onlinegdb.com. onlinegdb.com. Let's do that again. Okay, maybe I should paste it on the maybe I should paste it here. Don't worry. If I'm able to finish, if I'm not able to finish, I'm going to send you more codes that you can use. I'll send it through Emmanuel and Madam Edit. Shift F5. Okay. Please confirm you are there. Confirm you are there. onlinegdb.com. So you'll be seeing this. You'll be seeing this site here. onlinegdb.com. Are we there? Please confirm if you are there. That's why I want a response.
Yes, sir.
Temi and Marvin.
Yes, sir.
Yes,
sir.
Marvin is opening.
Yeah. Okay. That's your network there. So let's continue. So on the right like this, there's a feature there that's called language. Do you understand? We have different languages that this compiler can work for, but we are going for C. So you have to select C. Can you see? You have to choose C. So on my right hand like this, there's a language option there. So ensure you choose C. So also you have on this particular section here, the first menu here shows that you can create a new file. Do you understand? So you just need to write the title of that particular file. Then you click on OK. We are going to be using this for now. So the second one is upload file. If you've written your code internally, maybe on a notepad or something, you can upload file so that will help you to interpret it. Do you understand? Or compile it rather, or to help you compile it. So on the right hand side, so this is where it's very important for us that we are going to be using most of the time. You can now use your F9 or your keyboard, or just click on run to be able to see the output of whatever code you've inputted here. Do you remember I told you that on low-level language, we use what for comments? We also call it header, right? So we call it comment. So do you remember I said the / */, if you remembered, I think I wrote it down in my during my presentation. I think I did something like that. Let me just quickly go back there so that I can be able to remember. Okay, not here. Okay, not here. So I was trying to tell you what okay, this is it here. So if you remember, I was saying we have for low-level language, we use #. For high-level language, we use // for a single line comment. But for a multiple line comment, we use /*, then the contents inside. So that's why we're able to get that in that compiler. I'm trying to explain the compiler for you. So let's quickly move on again to see what other thing. So here you can run with display screen. So it's currently supported by Python. Okay. So you can just click on run, then you see your output down there. So down here, we have something called terminal. So your terminal will be shown down here. Once you click on run, your terminal will be shown down here. We are going to talk about it. Then this place, you can collapse it like this. It's movable or draggable. So can you see? You can drag it up and down to be able to see more of your outputs. So let me put that again. Here, you choose your language, C. Here, you come to run. Here, if you have a new file, I'm not creating a new file. Here, if you want to upload an existing file, then here is your interface for the compiler. Then down here is where you have your terminal. The terminal is where your output will be displayed. So quickly, let's move on and run through some of the things that I've put on this slide. Before I do that, look at this.
Sorry, Mr. Ayoola. I think Temi sent a screenshot to the chat room.
Okay. What's this? Okay. Online GDB. DB, not BD. DB. Check it, Temi. It should be DB. DB, not BD.
All right, sir.
Yeah, DB, online DB, GDB. Okay. Online GD. Have you opened it now? Confirm.
Yes, I'm there now. Thank you, sir.
Okay, good. Yeah, welcome. So you can decide to download your current file, also here. Beautified means that if this one is here now, look at this one now. Can you see? And this one is not well aligned. Can you see? And this one is somewhere very, very far from each other. So by press Control A and I click on beautify, then it will make it to be aligned. Do you understand? This alignment helps code to be very readable. So let me just quickly put you through some of these things. Look at this. You have your include stdio.h. Please remember that you have your int main file. We have your printf. I'm going to explain all this. You have return 0, and then you have your curly bracket. So I'm going to explain that to you right now. So understanding the program structure. Please permit me to remake this particular slide so that we all can benefit from it. Coming. Okay. Sorry, 1 second. Okay, good. Okay, so this is your code here. So let's quickly look at what each of the code really means. Remember I mentioned libraries the other time. Your stdio.h, it's a library, and it has to be imputed every time you are trying to do anything in C programming language. So it shows that an header file. So that H is the header, but a library within C. So you are including your studio header. So a header file for input and output. If it is not there, it will not work. Do you understand? When you are trying to run your code, it will not work. So everybody master this particular one. You have to ensure that it's there. Hash include space less than stdio.h, that is studio h, which is to declare that this particular compiler allows input and output of what? Of file. Let's go look at the main. The main is the starting program for every C program. This particular main here, where's my pen here? This main here, can you see, is a starting point for every C program. Is a starting point for every. So you have to first declare your variable string, sorry, int. Can you see? The other time we mentioned, short, int, and what? And, 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 long, right? So int can support as long as 16 and 32 bit. I told you the other time. So to be able to start that, you have to make sure that your starting point has a defined data type before you start. So this particular what's it called? Curly brackets now is the opening. Can you note that, please? Opening and closing of your code. Opening of your what? Of your C program code. The opening and the closing of your C program code. Then the printf, I've mentioned this severally. It's just to output. Are you getting me? It's used to print text. To print text. It's used to print text or output or output. Don't mind my writing. I'm using my mouse to write. So, or output. So it can be used to print text or output. So then the return 0 is just to tell you whether this particular program that you are trying to write is successful. This will return 0. It's going to tell you whether it is what? It is successful or not. Whether it's successful or not. So if it returns anything apart from 0, then it's not successful. But if it returns 0, that means that it is successful. Also note these strings, please. These strings, I call it string, this double quotes. This is where you put in strings. And what do you do with these strings is that it helps you to be able to print out anything within that particular opening and closing double quotes, because it's going to see it as a normal text. Do you understand? So let's quickly move on ahead. So this is an example. If I want to print up hello world, I just need to say printf hello world. If I want to say print numbers, maybe like 2, I just say print f into brackets 2. Can you see? So this print, do not f, this print c, don't mind my this c, print f, then 2. Let's go to print out 2. Let's quickly look at some escape sequences, because it's very important, because we're going to be using them to be able to run some of these things, and you're going to be able to see the output. Don't forget, I might not be taking you through the complex ones, but I'll just be giving you like 2 or 3 examples that I'm going to be done with this what's it called? We're going to be using it for this particular example. So look at this now. I have backward slash. There's a difference between backward, look at this, backward and forward slash. Some people don't know the difference. Please look at it on your keyboard before you start anything. There's a difference between backward and what? And forward slash. So backward slash n means that whenever you put this, look at this, hello word. I'm trying to write hello word. When I put backward slash n in between hello and word, that means that I want that word to move to the next line. Do you understand? That word will move to the next line. So it will not be hello, then look at the output here. Instead of writing it hello space word, look at our code here. Sorry, please. Look at it here. Hello word here. So by the time I add backward slash n, then it will do what? It will move that word to the next line. So let's move on. Backward slash t. What does it do? Is to add a what? A tab, horizontal tab. When you say horizontal tab, look at what I mean. Look at what I mean. See, not a space. So you know the difference between space and tab. So can you see? It will add a horizontal tab. When you say double backslash, then it will help you add backslash, a single backslash. Can you see? Look at the output here. Sorry, the example. Double backslash, then single backslash. So you can just take a screenshot of this on your phone or your laptop. You can take a screenshot of this, though it's going to be available in your material. But you will still need it. So look at this, backward slash a single quote. Can you see? Backward slash a single quote shows that you should do what? It should help you add double quotes at the end of A. Can you see? Add one single quote, add another single quote. So can you see? A is a character. So and so on and so forth, and so on and so forth, and so on and so forth. So if you want it to be making sound whenever you are done, just make a beep sound like pop. Do you understand? Like instead of returning 0 here, you can just say backward slash A. So what's my code here? I just say hello world backward slash A. Then it's going to return a beep sound. Pam. Do you understand? So this is the simple things that you really need to understand in writing, or the basics you need to understand in writing a C programming. Number one, your include, #include str.h to be able to what? To be able to add the header file. And I told you that that one will determine that it is what? An input and an output file for C. Then we have your main, which shows the starting of your C program, and you have to also ensure that you include your what? Your data type, which is the int. It's very simple. Just follow this procedure and you are going to be able to run everything. So let's quickly run our basic what's it called? Please confirm you can see my screen fully. F11. I'm on full screen now. So I think everybody should be able to see my screen fully. Let me see if I can close this thing. In this ad. Not interested in this ad. Yeah, good. It's distracting me. Sorry, I want to try and close all these ads. They're disturbing me. Sorry. Okay, good. I think I'm okay with this now. So please confirm you can see my screen. Everybody, confirm you can see my screen.
Yes, you can see
Okay.
your code here.
So now you can see the run. You can see the run here. You can see the language here, right? So what you just need to do is that this one has already been pre-written. This is the main hello world. So if you don't, peradventure, you don't have this on your system, what you just need to do is to ensure you have your #include. Are you getting me? You can remove this one. This is just this is just a comment. So you can remove that one. #include, then stdio.h, which declares the header. Don't forget, in start of your C program, which is the main. Are you getting me? This 0 is going to be returned because we declared it to return an integer value at the end. So don't worry, we'll talk about that complexities if we are opportune to. So printf now will be what? Hello world. That is what we want to do, is that output hello world. So everybody now, if you've done these settings, it's like this. Just click on run. You should be able to see your code outside there. Can you see the can I see it below here? Hello world. Please confirm if you can see it. Temi and
Yes, I can see it.
Yes,
were
sir.
you able to run? Were you able to run it also?
Yes.
sir.
Okay, good. So now let us add some of those escape sequences. Now let's add space \n. So everybody do that on your own too. I run it. Big space. Can you see? Because there's a space between n and word. Can you see the space between my own n and word too? So I just do what? I remove that space. Then I run it again. Can you see? So we call this particular black space terminal. So this is your terminal. So this is your terminal. So can you see now? So now I want you to add okay, let's say first program. Let's look at something that we can add there. Let's add a beep sound. That is \a. Then space \a. Then run it. Did you hear that sound? Please, my co
Yes, sir.
something, please let me be hearing
Yes,
your
sir.
voice. Did you try it?
Yes, I tried it.
Yeah. I don't know. Let us give those people in the chat room also the opportunity to do that. Did you hear that sound? And that person again, please, one person should tell us apart from Timmy and Marvin. I need one person to come. Talking. Okay, please let's move on. Let's move on because of time. Okay, I think somebody just dropped the chat now. Yes, sir, I had. Thank you very much, Emmanuel. So that is how those escape sequences work. So you might decide that you want to use them and you need to do something. Probably you can even do it like add an escape sequence and then add a sound here to sound twice. You are just playing with it. Look at it. Then it does it again. So then let's quickly do printing of no, let's add numbers. Let's do something. Let's add something like let's print out 2 lines of code. So what I'm going to do is that I'm going to say I'm 25 years old. I'm 25 years old. 25 years old. I'm 25 years old. The name of my friend. The name of my friend is Marvin and Demi. Okay, so now let's output these two. Okay, before I move on, tell me what's going to be my result here.
I am 25 years old. The name of my friend is Marvin and Timmy.
Is it going to write it on a straight line or it's going to move to the next line?
It's going to write on a straight line, sir.
Okay, Marvin.
Yes, sir.
So what is going to be our output for this?
They're going to get jumbled up together.
Yeah, so give us what is it? Just say it out. What will be our output?
It's going to be I'm 25 years old. The name of my friend is Marvin and Timmy on the same line.
So this is what I want to do. Let me just copy like this. I'm coming. I don't want to run. I don't want to run it yet. So this will be our output, right? Let's just say our output.
Yes.
Okay. So tell me, confirm if I'm right. Is this going to be our output?
Yes, sir.
Okay. So let's just run it together. Everybody, let's do it together. So write on your compiler and let us run it together. So it's going to give us on a different line. Sorry. Okay, sorry. I did not, I thought I put the N. It's going to give us on a straight line. And don't forget that you did not put a space in between this. Do you understand? So what do you understand by this is that if you don't put any of the escape sequences, are you getting me? You won't be able to get what you really want. So thank you very much, my good friend, Marvin and Temi. It will be together. So what do I need to do here is to add a new line, \n, then run it. Then it takes the name of my friend is Marvin and Temi. Another thing I can do here again is that I can add a tab to make a very wide space to be between old and the name. Look at it. Can you see it? Can you see the difference between them? Can you see it, people?
Yes, sir.
Yeah.
So yeah, so that is how all the escape sequences, that is how they really work. That is how they really work. Can we quickly do a little calculation before we go on? Please confirm if you've not been able to try this. You can try this on your phone too. It's the same thing. You can try this on your phone. You can try. Let me look at another. Let me just put our sound here so that we'll know that it's on at the end of the day. So I love that sound. So just put the sound there at the end of the day. So let me see another one that we can put there. Okay, so we have a lot of them. I only gave you that. You can always search for escape sequences in C. We have several of them. So please, can I clear this? Let me just quickly clear this so that I'll leave it to return. So I need to add two numbers. Do you understand? Two integer numbers. Let me say 5 plus 6. So don't forget that I told you the other time that I need to do what? To be able to have the data type first, that is int. I'm declaring the data type first. Then I will say num1. Then I'm going to assign a value into num1. That is 2. Right? So then I will say int again. Can you see what I'm doing? Num2 equals to what? Equals to 5. Right? So now, if I want to do this, then I'll say int now, sum will be the addition of what? Num1, can you see? Plus num2. Can you see what I'm doing? Please don't forget that we need to do this. Then we now need to print now. Look at this. Print now. F, right? Into brackets. Then I say sum now space. Then outside. Should I do that? Okay, so let me do that. Let me just say, because I don't want to input, I want to output sum. I just put sum inside directly. Then look at this. Please look at this, everybody. Look at this. Then I need to do one other thing. I need to do printf, right, into brackets, sum, sorry, together, sum, inside a string, sum now, then space, then I'm going to say, okay, before this, let me put it on the next carriage, next, sum now equals to, and outside it, then I'm going to put sum. Then I end it. So now, what we need to do here, let me explain what I've done here. Number one is that I initialized, sorry, initialized my variables with corresponding data type, int. I did that here too. Then here, what did I do here is that I also initialize my variables with corresponding data type and summed up the two, where is it? Two variables. So let's do like this. Initialize variables with data type so that you all see it. Please, I hope everybody's doing what I'm doing and summed up the two variables. Then here, I just outputted the variables. I output the what? The variables. Then here, look at what I did here. I added, or I output the string, or you can call it class or character or whatever you want to call it, and the sum variable. I think this should be very simple. Then this one is to return or show that the code was successfully run or run. Let's use run, but we run. Okay, So what do I need to do here? You just click on, okay, let me call my friends again. Marvin, you first now. So let me just explain. What I did here is that I assigned 2 into num1, 5 into num2. Then I'm now adding num1 and num2, which is 2 plus 5, and assigning it into what? Into sum. So what I'm not doing is that, do you see that I did not add, what's it called here? I did not add quotes in this particular sum because it will only print out sum. So if I do this, it will only print out sum. Do you understand? But I need to print out that variables. That was why I removed that particular string. So I just say sum. Then the next thing was that, okay, after printing this sum, which is sum is 2 plus 5. So it should give me the output of the variable of the sum, of the variable sum. And here I say, tell me that sum now is what? Sum. That is sum, semicolon, then sum. That which is going to be the answer that's been gotten. So once I click on run, it will give me my variable here. Coming, sorry. Coming. Hold on. It's giving me an error. Let me comment it out here. Let's run it here. May the format not string literal. Sorry, hold on, something is wrong there. Sorry, something is wrong somewhere. I need to quickly pick up. Okay, let's look at it again. Okay, let me change this to seeing this as errors. Where's my star? Should work now. Coming, where's star? Sorry, we need to change this to star. Seeing too much of literals. There's too much of words. Okay, thank you. Where's star? Where's star? So it permits me to do this. Then I'm going to do sum. Star. Scroll again. I'm coming. Something went wrong with my code, comma, son. Okay. Sorry, please. This is what went wrong with my code here. Please let me restart again. So I need to take off these literals. They are too much. So one thing that happened is I remember that I initialized my variables with the corresponding data type. I did the same thing here. I initialized my variable data type and it was sum of the two variables. So let me just limit them to this. So I limit it to this, then show that the code was successfully run. So now look at it, everybody. This XD shows that it should accept just integer. Can you see? So it was not accepting integer directly. It was supposed to convert it to a string. So I can say accept just integer. So that was why I had XD, that is the integer that is going to accept this particular number from sum. So now if I want to get this particular value from num now, so let's do like this. Let's do like this. So I'll say first number. To be able to show that particular first number, what do I need to do? Is to add xd because it's an integer, it's not a string. So then all I'll do there is I'll just say num1. Can you see xd? There's some num1. So this one will change this particular num1 into a string. Do you understand? Then this other one, xd, I want to change it to second number. Then you add the xd to be able to ensure that this is an integer. Then you say num2. So it's going to add the num1 and what? Add the num2 together. Then it's going to give you what? So we're gonna say sum of first number and second number equals to, let me remove this one, equals to then xd. Then don't forget, if you don't put the escape sequence, it won't go to the next line. Oh, n. If you don't put the escape sequence, it won't go to the next line. So, sorry, not this one. It should not be here. Okay, yes, I'm right. So let's run it. So first number is 2, second number is 5. So sum of first number and second number equals to 7. So now if I want to do for subtraction, so all I just need to do is what? Int subtraction, subtract. Let's just do like this, subtract. So equals to what? Num2 minus num1. Then you end it here. Then say print now is subtraction of second number from first number equals to, then subtract. You change this particular variable here, subtract. Then don't forget that there needs to be a what? A escape sequence here to let it go to the next line. So can you see? Subtract now. Then I think I'm right. Then minus, it should be minus here. 1 is plus. So it's going to get the sum and the subtraction. So let's add it together. Plus. Now can you see? First number 2, second number 5. Sum of first number and second number equals to 7. Then subtraction of second number from first number equals to what? 3. That is 5 minus 2. So let's do addition. So let's do addition. Okay. Marvin and Tammy, please quickly do multiplication and division. So okay, now let's do division, because by the time you're doing division, We are going to be having a float number. We are going to be having a float number. Or you can do division. Yes, let's do division. So let's say int. So I want to see your screen, Marvin and Temi, quickly. After this, I want to see your screen. I want to see your screen after this. So multiply equals to num1 multiply times num2. So I think I'm going to be stopping at this particular section for today. So I'm going to come and print it, which is outputting. So I'll say multiplication of first number and second number equals to, then I pick my variable here, then I output it here. Then I'll do for divide too. So divide should be division should be num2, the greatest one divided by the highest number divided by the this one will be divide. So then I'll do division of second number. So I want to see your screen, Temi, and of second number and first number, and that will be divide. So by the time, don't forget to add your escape sequence. Your escape sequence. So this one now, 5 divided by 2 will give us 2.5. But it should either approximately to 2 or to approximately to 3. Do you understand? Because it's an integer number. So let's go. Let's run. So can you see? So it approximated it to 2. It did not put the float. So if I change this one to float now, and I say divide, where's my divide? No. Floats. So how did you get this second number coming? How did you get minus 87 minus 87? Which one taking? Something is wrong somewhere. Okay, let's quickly use our interpreter because of our time.
Sir,
Yeah, I'm coming. Sorry,
I
1 second. I'm coming. Okay, I'm listening to me.
all right, sir. I did the multiplication and division, or for my division I got 0. Something.
Is it checking num1 divided by num2? Is that what you
Yes,
did?
yeah, I've seen it
Uh-huh.
again.
So
Yeah.
if it's num1, you know it's 2 divided by 5, it will be
Yes.
0.4. Yeah. Okay. So you want to share your screen, right? So I don't know, maybe you take this screen. Let me see if I can screenshot this. Let me please screenshot this.
Sorry, can I take a screenshot instead, or you snap?
Okay, take a screenshot and send to me then. Take a screenshot and send to me. So that everybody that wants to use this, I'll put this in your materials too. So it will be available there. So I'll try my best to be able to send something to you again during the course of the week so that you can I'll help you come up with some of the tasks that are always available or some of the examples so that you can also run some of these things. So in like 2 minutes to end this class, I don't know if I have any question from anybody. Marvin, I'm still expecting your own what's it called? Your own screenshot too. Okay. Any question before we move ahead?
So I have a question.
Okay, thank you very much. Tell me, I'm listening.
For the return zero, the last line that shows return zero, what if we don't add
Yes,
return zero? Would this still run?
it will run. You can test it, it will run.
Yes, because mine ran. I wanted to be
Yes,
sure.
the reason why we are doing that is so that you'll be able to see that that code worked. Do you understand? So just to
Yes,
show you
sir.
that the code work. So that's why I'm putting 0 there.
Okay, but it's not display on the
Yeah, it will not
other
display
end.
there. Yes, yes.
All right, sir.
Okay. Okay, thank you very much, Marvin. I can see your code too. Ah, you can see? Okay. Okay, beautiful. Thank you, guys. Any other question? Any other question? You can see that it's very simple. C programming or how to write the program or how to write the programming languages. So to be able to choose the best language for yourself, starting from C is a very great fundamental for high level programming in case you want to go into it. So I'll try my best, maybe on Monday or Tuesday, I'll try to send something through the coordinator so that they can give you. So by the time we see on Friday, we'll be on Saturday, like this time again, uh we'll be able to discuss if anybody had challenge running their simple C programming. Okay. Any other person? Do you have any other question, please? Any other question? Okay, thank you very much, everyone. Thank you for your time. It's been a very long hour together. I hope to see you again on Saturday. Thank you, Madam Medi. Thank you, Emmanuel. Over to you, Sas.
Yeah, thank you so much, Mr. Ayoola. Now we've come to an end of the first session of today's class. Before we continue, please, if you're not on the Telegram community, because every information, every material passed from the trainer will only be posted on the Telegram community. So please, if you're not on the Telegram community, I just posted the link again in the chat room. Please do well to join. And also, the feedback form. Please let's take a minute to fill that up. Let's just take a minute to fill the feedback form up before we add um, before we add before we leave the floor for Miss Naomi to take us through on the cybersecurity side. So please take a minute to fill the feedback form. And to join the Telegram group, a minute to do that, please. All right, okay. Now it's past a minute. So we officially bring the software application development session and we start the cybersecurity session now.